Hi chaps, and welcome to our next lesson or our next video lesson. Today the topic is going to be on levers, but to start, before we do our recap task, I'm just going to go through very briefly the 9 mark question that I set you on warm up and cool down. Right, so first of all, we're going to make sure we look at the question and we answer what the question is actually asking us. Okay, so we already know that it is an evaluate question. Okay, so we've got to give both sides and conclusion. That is really important. And it's asking, does one benefit the other? Okay, or is one more beneficial than the other in your opinion or based on the evidence that you have? So you're going to split it up into two. Obviously, we like to have 3 boxes as such, all right, but this type of question doesn't lend itself to that because it's a warm up and a cool down. So if you start with the warm up, we know we've got to go through the process of AO1s, AO2s, AO3s. So to not spend too much time on that, our AO1s and our AO2s, okay, should have the 4 parts with examples. And in your booklets, okay, you've got clear ways and linking words, all right, but things like such as, for example, should be used when we're linking to AO2s. You will also need to do the same thing for the cool down, all right. So if I was going to stick to this, and I go back to, I'll sort of scroll down in a moment. If we went to the cool down, exactly the same for AO1 and AO2. You go in with the 3 parts with examples. So that would be our 2 boxes ultimately. Okay, so if we then scroll down, so let's say we've done all of that, and I'm just going to go back to the warm-up start now. So if I went with warm-up again, if I just went with warm-up, back to warm-up. So you've got to outline the benefits. He's saying this lasts 10 minutes, cool down roughly 20. And if I'll just quickly go back to the question, because obviously I've highlighted some of the key things here. But if we just zoom in on this question a moment, let's have a look at the context. So he's looking to be an Olympic level competitor. Okay, it is swimming. All our examples need to be linked to swimming. It tells us he trains a lot, right, 6 days a week, and competes. Okay, sorry, competes is up there. That's completes. And then it's got warm down and cool down, or warm up and cool down. 10 minutes on the warm up, 20 minutes on the cool down. So ultimately, he is spending more time on a cool down, less time on a warm up. Is that going to benefit him? Is that going to help improve his performance? All right, so everything needs to be linked when we're going AO3 to improving his performance. Okay, so let's go back down to where I was before. So if we have a look at back to the warm up, all right, so I'm just going to delete this cool down bit a moment, get that out of our way. So I'll warm up. What are going to be the benefits? If he's only spending 10 minutes, you could say the benefits are going to be limited. Okay, so it is reducing injury or chances of injury. Okay, it is helping him practice his skills. It is getting him mentally prepared. It is increasing his range. I'll just put Ron, but increasing his range of movement. So those are the part A3s that you're going to mention. How's that going to help improve? So less injury equals more training equals improvement. I'll just put improved performance. Practice the skills. Improved technique. That's going to help improve performance. Control of arousal. get to the optimum equals improved performance. Range of movement and flexibility. Let me just add and flexibility. I'll say flex there. But improved, oh am I going here? Improved flex. That looks terrible. So let me start that again. The pen was having a bit of a mare there. So improved flexibility equals, you could argue things like greater power, longer stroke, decreased time, all of those different things. Okay, so those are our basics for the warm-up. All right, I haven't really linked it to swimming, all right, but more training, improved technique in terms of the way he, depending on what stroke you're talking about, the way his hands enter the water, the way he pulls through, can he generate more power, can he improve various different parts, can he improve his start, he might practice his starts, so he gets, I quite like that one, all right, so his starts, similar to our athletes who we talk about, improved start means improved time. Basically, they get away from their opponents quicker, put the pressure on. That's going to help improve the performance. Controlling arousal means he doesn't false start. Okay, means he's not going to be too keen off the blocks. It'll pace his race better. All those different elements. And in flexibility, again, I think it goes in quite nicely with the improved skill scenario. Loads of different options we could talk about, but he is only spending 10 minutes on that. All right, so you could argue the other side of the coin for this one. All right, so not spending enough time. Not enough equals increased chance of injury due to the amount of training. He's doing. Okay, increased chance of injury. Not giving himself enough time to practice his techniques, control his arousal, based on the 10 minutes. If we then have a little look at the cool down part as well. All right, so we've changed this to a cool down. Benefits in terms of performance. So we know we've got the reduction DOMs. I'm just going to put removal of waste for now, and that includes everything. Removal of waste. How's this going to help? Recover quicker. Equals more training. Equals more events. Equals more practice. Equals improved performance. If we talk about the improved flexibility, and that's range of movement, and similar to what I said earlier, so the increased range of movement equals technique, better performance, all those different elements. You then got to conclude as to which one you feel is the most important, based on the questions. If we go back to the question again, I'll just scroll up very, very quickly. Go back to the question. Evaluate whether he is gaining more benefits from doing a longer cool down than the warm-up when trying to improve his swimming performance. That's up to you based on what you've got. Personally, I actually think it's the other way round. So I would actually say, in conclusion, that is terrible. I cannot. My writing's poor, but I can't leave it at that. So, in conclusion, less benefits. This is just me. Less benefits from cool down. More from warm up. So I'm saying should spend longer on this. You could say or equal amount of time. You could also say, and this is where we bring in other parts, other aspects of recovery could be used. So I'll just put DM, diet manipulation, and ice baths might be more effective, which will then help improve his performance because he'll be in a better condition. Okay, so hopefully you've included, I mean, I would have had a look at these, or I will be having a look at these next week, but hopefully you've included some of these aspects within your 9 marker. We will go through these fully in class when we actually get back into school, but hopefully you've included some of those aspects that I've just outlined in your 9 mark answer. So today's topic is going to be levers. As ever, you will need your paper 1 workbooklets that have all the questions in. You will need lined paper or plain paper to make notes and take part in the tasks I'm going to ask you to do. You may need your paper 1 Bibles just to check a few things. And then as ever, submitting the work after the lesson via email. And I'll explain that as we get to the end. Now, this is a notoriously difficult topic. It is a topic that I found particularly difficult when I was at school, and in fact when I was at uni as well. And it took me a long time to understand it. It is actually very, very simple. I'm going to keep it as simple as I possibly can for you. But as I said, you may struggle with it as we go through this, but just try and listen to what I tell you. Look at the examples that I give you, and if you learn it how I'm about to show you, you shouldn't have any problems. Okay, let's get on with the recap task. Right, so on with the recap tasks as usual. So, 2 questions on your screen. Can you name 4 parts of the warm-up and 3 parts of the cool-down? Stuff that we did in the previous lesson. Let's go, 1 minute maximum. I'll put some things on the screen for you as we go. So 4 separate parts of the warm-up. And then there should be 3 separate parts of the cool-down. I've got 4 in there, but we don't need this one. Okay, you've had 30 seconds so far. So I'll start putting some letters on the screen for you. This pen isn't working particularly well. So we have got the P, the S, and the M for parts of the warm-up. And then the M, G, and the S for the cool down. Okay, that is a minute gone. So let's have a little brief recap then. So should have pulse raiser. This pen is not working well in this lesson today. Pulse raiser, followed by stretching. And that can be static, or I'll just put dynamic. Then should have skills, or skill-based preparation, and then mental preparation. I'm just going to put mental prep. If we then go to the cool down, okay, so maintain, that's what I was looking for, HR and BR, gradually reduce intensity, and then good old stretching again. Right, so that's 2 questions. We've got another 2 questions to go. It's going to scroll down, so we'll just scroll down and out slightly so you can see them all. So now, can you give me 2 benefits of a warm-up and 2 benefits of a cool-down? Not sure, there are more, all right, so I'm not fussed which ones you use, all right, but 2 and 2. And then 3 limitations of fitness testing. There are 5 you can have, I want 3. Again, you've got a minute, off you go. So I'm going to put the two that I would probably like to see. I'm just going to put an I. Which one should I'm just going to put an arrow. That signifies quite a few things. Cool down. And so a down arrow and an R. And then limitations of fitness testing. I'm going to put S. Which one shall I go for? C, V. Okay, so benefits of the warm-up. Injury prevention was the main one I wanted to see. I'll just put injury prevent. Increased body temp you could have. Muscle temp. You could also add in there then some others. So focus or arousal control. What else can we have in there? You can also have skills practice. Any of the others that you can think of. Those are our main four that you're going to talk about if we're going to link them to each of the elements. You might have also put in there increased flexibility / range of movement, so ROM. Cool down. All right, so reduction in terms of DOMs. So remember, it just reduces the effect. All right, and then you've got removal of waste. I'll accept any of the waste. So in terms of lactic acid, CO2 or toxins, I'll accept any of that. And I'm happy with those in terms of our answers. Okay, and then limitations of fitness testing. Not done this in a while, all right, so I imagine we struggled very, very slightly. So the S was specific, all right, in the fact that they are not specific to sports a lot of the time. The C was they don't replicate the competitive nature of sports. All right, so I put rep. Oh, rep. Let me just delete that a moment. So they don't replicate the competitive nature of sport. They also don't replicate, I'm going to put the movement in there as well. Don't replicate the movements within sport. There are issues with validity. So you must go through the correct procedure each time. There are also issues with reliability you could have had as well. In terms of sometimes they're sub-maximal, where actually movement is maximal. Okay, so any of those, again, we're trying to recap some of the stuff that we did just before we broke up so we don't forget it. I'm going to be setting some tasks in the not too distant future where we're going to be going over everything that we've done in terms of our AO1 tests. Okay, so let's get on with the main part of our lesson now. So levers. Levers is split into two parts really, and I'll explain them both now. Now, levers is a very difficult topic, or I wouldn't say it's a very difficult topic, but it's the one that students struggle to understand. I talked about this earlier. I struggled throughout school when I was taught levers. I actually struggled throughout university as well. And now I'm teaching it. I actually find it very, very simple, and I wish I was taught the way I'm about to teach you when I was younger, because it made it very, very simple when I was shown it. Okay, so in terms of what we need to look at, you can see on your screen, name the three components of a lever. Very, very simple AO1. Identify the points of a lever on a diagram, so we have to show and be able to draw a diagram, and link the levers to anatomical body parts or joints. Okay, so that's movements. So things like flexion, extension, and shoulder, elbow, knee, ankle scenarios. Okay, so that's the first part of our levers. The second part of our levers is something called mechanical advantage and disadvantage, and that's basically what are the advantages of certain types of lever and what are the disadvantages of certain types of lever. Again, you can see on here, label the effort and resistance arm on a lever, okay, and know the equation. And then you also need to justify why one lever has a bigger mechanical advantage than another, and I'll make that pretty clear a little bit later on. Okay, so let's go on to the first part of levers. Right, so let's just scroll across and down and let's make sure we understand what levers are before we get going. So, levers, to keep it as simple as we can. What are they? They are linked to muscles. Oh, what is going on here with my writing? Worse than normal, I apologise. Linked to muscles, bones and joints. Secondly, they show or allow us to see how force is applied through joints. And lastly, clear link with movements. And what I mean by that is that we've got our different types of movements or joint movements. So things like flexion, extension. You could say adduction, rotation, circumduction, all of those. Okay, it has a massive link to those. You'll be asked to look at pictures, tell us what the movement is, and then link in the different levers. Now, the levers have 3 parts. Right, there are 3 parts to the lever. Right, and like I say, it's all about how we produce force, but there are 3 parts. There is a fulcrum. You can see it in the picture below. Right, but a fulcrum, we always draw it as a triangle. There is an effort, which is always an arrow, and sometimes it's up, sometimes it's down. Okay, and you can see it there. It's down on all of these, but sorry, no, it's not. It's down on a first class lever and up on the other 2. And then there is a load, and sometimes it's called a resistance as well. It doesn't matter which one you call it. I'll put both, load or resistance. On here it says an arrow, right? But I always draw it as a square, and that will make sense as we get through to the drawings of the levers. These are what levers look like in their simple form. This is what we're going to learn to do, but I'm going to explain it a little bit clearer than just showing you some pictures like this. Now we know what they are. Let's just have a very quick look at how we are always going to remember levers. Now, any time we talk about levers, you are going to write this on the page. I'm going to scroll. So anytime you are going to write 1, 2, 3, F, L, E. Exactly like this on the page. Doesn't matter how big you write it or how small you write it, but anytime we're doing revision, anytime you're taking notes, anytime someone talks about levers, you are going to remember 1, 2, 3, F, L, E. Okay, now the reason for that is it helps you remember where and how to draw your levers properly. Now, I wish I would have been taught this when I was younger. Like I said earlier, I struggled with levers all the way through university. I was then shown this method, and it's so easy, and I understand it fully now of how levers work and what we need to do with them. So anytime we talk about this, 1, 2, 3, FLE, and you're going to see me do that a few times during this lesson as we go through the drawing of it. But anytime in any lesson you do, or any question you have, any exam question or in any exam that you do, and it's a levers question, just write down 1, 2, 3, FLE, and you shouldn't go wrong with the rest of the question. So I'm going to scroll across and up slightly. So we're now going to have a look at the different types of levers. Now, levers. There are 3 different types that we need to know about. And they're very, very simple. They've got very simple names. All right, but we've just got to be clear on how we do them. So you have your first class lever. So first class lever. They're sometimes called orders as well. So first order lever or first class. We're going to call it first class lever. You might see it as first order, but not all the time. But first class lever. The next one is called a second class lever. And the third one is called, no surprises, a third class lever. Those are the names. Very, very simple. Do not, and I'll repeat this, do not call them number 1 lever, number 2 lever, number 3 lever. Must call them first class or first order lever, second class lever, and third class lever. Now, when we have a look at the different types of levers and what joints and movements they're associated with, if I go into first class lever to start off with. So, movements. With first class lever, it is elbow, L-lob, elbow is what we want, not L-lob, elbow, extension only. Let me just rewrite that as well, having a mare with the pen here, sorry chaps, only. So whenever you see a picture that is elbow extension and you're asked to name the lever, and we'll do a few tasks on this in a little while, elbow extension is a first order, first class lever. It's the only movement we have to know about with a first order lever for this course. Okay, so you can see in the picture, I've given you an example. That's the follow through of a line out throw. Right, but any follow through movement of a throw is going to be elbow extension, whether it's a throw in football, the end phase of a javelin, a shot in netball, any of those elements, elbow extension is going to be a first class lever. When we have a look at a second class lever, the movements we are worried about, or the joints we are worried about, is the ankle only. Ankle only. Now it doesn't matter if it is plantar or dorsal. It is any movement that is ankle only. So again, keeps it quite simple. That's a second class lever. And then a third class lever is any other movement. Any other movement that obviously is not the ankle and not elbow extension. So elbow flexion, okay, flexion and extension of the knee joints, flexion and extension, abduction of hips and shoulders. Any of those movements are a third class lever, but not ankle and not elbow extension. If you're in any doubt in an exam, or you look at a question and you still don't understand it, put third class lever, because that is the majority of our levers within the body are third class, with only this obviously a very small number of movements and joints that are second class levers. Now, I've given you the names and I've given you the movement types they're associated with. We've now got to be able to draw the different types of levers. So I have a little look down here at my empty seesaws at the moment. I showed you them in full earlier, but I'm going to draw them so they make a little bit more sense to you now. So if I go to our first lever that you can see here, okay, I'm just going to move this down very, very slightly to make it easier so we can all see them. But we will be given, and you'll see it in a question in a moment, we'll be given a blank box and be told, can you draw a first class lever, a second class lever, or a third class lever? Or we might be asked, can you identify a lever first and then draw it? So you are just going to draw one of the seesaws once you've identified it. Now, as soon as you've got a drawing task, first thing you are going to do again, if you haven't already, is write, not scroll down, we are going to write 1, 2, 3 F, L, E in the bottom corner, just so we remember it. Okay, it doesn't matter where you put it. 1, 2, 3 F, L, E. Now, to draw a lever, all you've then got to do is look at your 1, 2, 3 FLE. If you have identified it as a first class lever, that means the F that is underneath it is the fulcrum. Okay, so as I explained earlier, there's 3 parts: a fulcrum, a load, and an effort. Okay, but from our diagram, our 1, 2, 3 FLE diagram, fulcrum will be in the middle of our seesaw. Okay, if it was a second class lever, so if we'd identified it's a second class lever and the L is underneath it, the load is going to go in the middle of the diagram. If it's a third class lever, and we've identified it's a third class lever, the effort is going to go in the middle of the diagram. Okay, or I'll put that in the wrong place, I'll put it up at the top. Okay, so the effort is going to be in the middle of the diagram. So what that means is our diagram of 1, 2, 3 FLE, whichever letter is underneath the number, that is going to go in the middle of our seesaw. Then it doesn't really matter where you put the other 3 elements of, the other 2 elements of the lever. So if I was going to put my load on this first class lever, I can put it on this side. And for this one, okay, the effort arrow actually points down. If I'm a second class lever, the fulcrum will go on one end and the effort on the other. And exactly the same here. All right, fulcrum on one end, load on the other. Hopefully you can see there, that makes it simple. It doesn't matter where you put the load. So if I rub this out again, it doesn't matter where you put the load and the effort on these, or the fulcrum and the load. It doesn't matter as long as you've got the correct one in the middle, which our 1, 2, 3 FLE helps with. All right, so I could put the load this side and the effort there. Okay, I can put the fulcrum this side and the effort here, and I can do exactly the same this side. All right, this is the same diagram. It's just making sure that we get the middle one correct. Okay, now once you've drawn the diagram, you're always going to be asked to label it. Now, do not just put letters. You must clearly label the diagram. So first of all, you are going to write, and I'll do this in green this time, you are going to write, this is a first class lever. That's your first part of your labelling. You are then going to make sure you have written fulcrum, effort, load. And you'll see that sometimes called resistance. You do exactly the same again here. Effort, load, fulcrum, load, effort, fulcrum. So that's how you draw your levers. Again, 1, 2, 3 FLE, whatever the letter is underneath the number, that's going to be what is in the middle of your drawing, or the middle of your seesaw. Okay, so just a quick recap again. A first class lever is elbow extension only. To draw it, fulcrum goes in the middle, load, effort either side. Second class lever is ankle movement only, whether it's plantar flexion or dorsiflexion. Okay, load in the middle, effort and fulcrum either side. And then third class lever is any other movement that we have, okay, with the effort in the middle, fulcrum and load either side of it. Okay, so those are our levers. Now I've got a quick task for you. There's going to be 6 pictures that I'm about to show you. and they're numbered, and I've also given you the joint that we're going to be focusing on, or the joint movement that we're going to be focusing on. I'm just going to give you 2 minutes to look at these pictures and decide what levers you can see. All right, so I've just done a lot of explaining there. I now want you to put it into practice. So I'm just going to scroll down and get these 6 pictures on your screens for you. These are our 6 pictures. So what I want you to do, 2 minutes I'm going to give you here. All right, and I'll give you a little hint as we go, but 2 minutes. Can you identify what the movement is and what the lever is then going to be? Okay, is it a first class lever, is it a second class lever, or is it a third class lever? All right, so number 1, you can see I've put a circle around it, is what movement is that at the elbow, and then what lever is that? Same with number 2, what movement is that at the elbow? So what lever does it make it? 3 is the knee, what's the movement? What's the lever? 4, exactly the same as at the ankle. 5 is at the elbow. 6, give us 2. All right, so knee and ankle. All right, you've had about 30 seconds while I've been talking there. So you've got about a minute and a half to go. Decide which one you think. Think of the movements first, and then that should give you a good idea as to what the type of lever is. Okay, you've had about a minute so far. Got about 45 seconds to go. Like I said, think about the different types of movement. Is it extension at the elbow? Is it flexion at the elbow? What movements is it extension or flexion at the knee? What's happening at the ankle? Is it plantar or dorsiflexion? Does it even matter when we're talking about levers? Probably not. All right, little clue there for you. But just write down which ones you think. First, second or third class levers. Third class levers. Okay? 30 seconds to go on that task. Okay, so that's 2 minutes. Let's see if we've understood the different types of levers. So if we start with number 1, the movement you can see there is elbow extension. Okay, so this is extension, which means automatically that is a first class lever. Okay, first class, because elbow extension is the only one that is a first class lever. Number 2, this is elbow flexion. So if it's flexion, that automatically means it is a third class lever. Third class, elbow flexion. Okay, that's a third class lever because it's one of our any other movements that we talked about. Here we've got flexion at the knee. What does that make it? That makes it a third class lever even. If we come down to here, ankle, at the moment, that is, you could argue that is plantar flexion. Doesn't hugely matter here, all right, because it will just ask you for the lever type. But if it's an ankle, that means it is a second class lever. Second class. We then have a look at number 5. That's extension at the elbow again. That makes that a first class lever. And number 6, I've asked for knee and ankle. If it's knee, doesn't really matter about the movement if we're talking about the lever, but that is going into flexion. Could argue extension as well if you really wanted to. That makes it a third class lever in terms of the knee, and then the ankle we know is a second class lever. Okay, so that is our different types of levers in a sporting context. You'll see in the questions that we're doing in a little while that they're very, very similar to what we've just done there. The task we've just done there is very similar to exam questions. You'll just be asked to look at a movement from point A to point B and identify what's going on and then maybe draw a picture of that. Okay, so let's move on to the second part of this now, mechanical advantage and disadvantage. Now, basically, This is what advantages do certain type of levers have and what disadvantages do certain type of levers have. Now, you are very, very unlikely, or you won't, for GCSE, be asked about first class levers advantage. Okay, mechanical advantage and disadvantage. You will not be asked about that, so you don't have to worry at all. You will be asked about second class or third class levers. Now, if you were asked about first class, and I said you wouldn't, all right, exactly the same as the second class for now. But mechanical advantage and disadvantage. Now, second class levers, they have a mechanical advantage. Right, they're known as a lever that has a mechanical advantage, whereas third class levers are actually mechanical disadvantage. I'm going to talk about both, so you're able to answer the questions. But if we have a look at second class levers first of all, so let me just give myself a bit of space. So mechanical advantage, I'll just put AD for now. So AD, so what's our mechanical advantage? If you have a look at this type of lever system, okay, it can lift heavy loads. Lift heavy loads. Okay, when you look at the picture I've given you above, the heavy load is actually the body. All right, so this small lever down here at the ankle, right, that is producing plantar or dorsiflexion, okay, is lifting our whole body up. Okay, and actually we don't have to use a huge amount of effort for us to be able to do that, and that is our second advantage, in the fact that little effort is needed to be able to lift heavy loads. Little effort needed. Okay, so those are our advantages. If I was then going to go to some disadvantages of this lever, or the mechanical disadvantage as such, okay, it would be that it has limited range of movement. Okay, so limited range. Limited range of movement. And the movements can be suggested to be slower, so slower movements. When we go across to our advantages of a third class lever, I'll just scroll back up here. Okay, so this is our third class lever. This is normally talked about as mechanical disadvantage, right? But I'll just talk about the advantages of this one first. Okay, so advantages: large range of movement, just the opposites really. Large range of movement, I'll just put large ROM. Large range of movement. Powerful / quick movements. And then our mechanical disadvantages for this, okay, are that it requires lots of effort. And cannot lift heavy loads. That's our mechanical disadvantage. Okay, so most of the time you'll be asked about a third class lever is what is the mechanical disadvantage, and for a second class lever you'll be asked what's the mechanical advantage, because it has a mechanical advantage whereas a third class doesn't. But you may be asked about both the advantages and the disadvantages of that type of lever. Now, to add another element of complication here, and I don't want us to get too bogged down by this, but we also need to know an equation for the mechanical advantage and disadvantage of these levers. Okay, so shall we start with the equation? Yeah, so we'll start with the equation. Okay, so it's called the mechanical advantage equation. Okay, so all it is my pen working? Yes. So mechanical advantage equals effort arm effort arm, and I'll explain this in a moment, divided by resistance arm. So that's how you find out whether there's a mechanical advantage or disadvantage. That's our equation. Now, to explain that further, and like I said, I don't want to get too bogged down by the mechanical advantage equations, okay? But when you look at a diagram, it has something called an effort arm and a resistance arm. So if we look at our second class, I'll zoom in on this one. If we look at our second class lever here, okay, our effort arm is the distance between the fulcrum and the effort. That is our effort arm of the equation. Effort arm. Effort arm. Okay. Our resistance arm is the distance between the fulcrum and the load. Okay, so that is our resistance arm. So you can see on a second class lever, it has a large effort arm, but quite a small resistance arm. Right? That means it has the mechanical advantage. That means it can lift those heavy loads. It can produce that type of movement, right? But it's that inflexible, slower movement that we can get. If we have a look at our third class lever, it is the complete opposite. Okay, so you can see here, our effort arm, it's still the distance between fulcrum and effort. All right, so that's still our effort arm there, but it's a lot shorter. Effort arm. But you can see our resistance arm up here is much longer. That's our resistance arm. That is much longer. That means it can produce, that makes it have a mechanical disadvantage because the effort arm's a lot smaller. But what it does mean is this type of lever produces quick movements, but takes a lot more effort to do. Right? So it's those quick, powerful movements. Not much weight can be involved, or not much resistance can be involved. Okay, but takes a lot of effort to get the movement completed. Okay, so I appreciate that's quite confusing. All right, but we do need to know how to calculate mechanical advantage, and that's how we do it. So if I just come out of here again, so you can see mechanical advantage equals our effort arm. So if I just highlight, let me just highlight this. So here we go again. So our effort arm, okay, is this bit here again. So that would be this bit, effort arm, divided by our resistance arm. Let me just change the colour of that one actually. We'll go blue, shall we? Or we'll make it slightly green. So our resistance arm, which is this bit here. In a second class lever, effort arm is big, resistance arm is low. All right, so the distance, and it's calculated by distance, will then give you the mechanical advantage of that lever. Exactly the same with the third class lever. All right, but you can see here, our effort arm is much smaller. Our resistance arm is much bigger. Okay, so when we divide the two together, we get a mechanical disadvantage on that one. Okay, so I hope that's helped a little bit. I appreciate that might be confusing coming over from a virtual lesson scenario rather than me talking it through and explaining it fully in a lesson. Now, if you've got any issues, do not worry too much about that equation. Right? You could be asked about how do you calculate mechanical advantage, and you've just got to remember effort arm divided by resistance arm. But most of the time, and you'll see the questions we're about to do, most of the time you're going to just be asked a mechanical advantage or mechanical disadvantage of the lever that you have identified. So if you identify a second class lever, advantages: lift heavy loads, very little effort. Disadvantages: limited range of movement, and the movements are a lot slower. If it's a third class lever you've identified, advantages: it's got a larger range of movement and the movements are powerful and quick. The disadvantages of it are that there is a lot of effort needed to produce the movement, and the loads that it can lift are very, very limited and quite light. Okay, so Now let's try and put that into a bit more practice and a bit more content. I appreciate I've been talking there a fair bit, but let's see if we can now put this into a little bit of practice. So here is a question for you. I want you to attempt this question here. Okay, so it's the question that's just popped up on your screen right now. Greg Rutherford won a bronze medal in a long jump at the 2016 Olympic Games in Rio de Janeiro. In the takeoff phase of the long jump, Greg Rutherford used a second-class lever at the ankle. Draw a linear diagram of a second-class lever. So that's asking you to draw the seesaw that we went through earlier. You then got two other questions. Explain why a second-class lever system has a high mechanical advantage. And then identify two types of movement that occur at the ankle. I just want you to very quickly, I'm going to give you 2 minutes here, and pause the video at this point to answer, and then we'll go through them. But pause the video, draw your lever, and then answer, explain why a second class lever has a high mechanical advantage. That might catch some of you by surprise, but think about what we've just talked about, okay? So pause the video now and attempt the question. Right, chaps, so answers to this first question. So you've had a bonus here in the fact that the question is actually giving you the lever. You don't have to identify the lever. It said it's a second class lever and it said it's at the ankle. So the first thing we do in this question, and I taught you this at the start, is straight away in the top corner, you are just going to write 1, 2, 3 FLE. Just so you do not mess the question up. 1, 2, 3 FLE. Okay, then that's going to tell us exactly how to draw and label our diagram. It doesn't say label there, and it is only 1 mark, but you must get into good habits of labeling your diagrams. So we know it's a second class lever. So on our little diagram, we know that our L, so our load, is going to be in the middle of our diagram. So you would use a ruler for this one, but I'm just going to freehand. That's our seesaw. Load goes in the middle. It then means the fulcrum can go wherever you want it to. It then means our effort can go on the other end. We must then make sure that we label it, just in case it is only a 1 marker, but these can quite often be 3 markers. Load, fulcrum, and then just for good measure, I'm going to put up there second class lever. Okay, now hopefully yours looks like that. Just remember 1, 2, 3 FLE, whatever the letter is underneath the number goes in the middle of our seesaw. Second question I ask you to do, explain why a second class lever system has a high mechanical advantage. Now, this doesn't say what are the mechanical advantages. It says explain why it has a high mechanical advantage. And that's why I thought it might catch some of you out. So you ultimately have to explain that equation that I just went through. So what you would say is, first of all, you put the equation. Sorry, let me just start that a bit better. So you would have, I'm just going to put MA, all right? So mechanical advantage equals effort arm divided by resistance arm. You must do that in full wording, okay? Not letters the way I've just done it there, okay? So do not abbreviate when you're doing this. So there's that tick 1 mark. You would then say it has high mechanical advantage because it has a long effort arm. Long effort arm. Oh, arm. Meaning distance. And I'll shorten this. So meaning the distance between fulcrum and effort is large. And then just for good measure, okay, this means lift heavy loads. You don't necessarily have to put this, but I think it's good. Lift heavy loads with little effort. If it was a slightly different question, so it might say explain the mechanical advantage of this lever system, you would then say it lifts heavy loads and it requires little effort for those heavy loads. But it's actually asking you to explain why. And that's why we have to put the equation in and we have to talk about the resistance arm and the effort arm. That's why I did that earlier in that explanation. Okay, so let's go again. Another set of questions for you to attempt. All right, so they're on your screen again. Don't worry about the one below at the moment. Just worry about the rugby one that I'm just showing you. So, figure 1 shows a rugby player throwing a ball during a line out. Position A to position B. If I just scroll across slightly here, it's a 3-mark question. Using figure 1, name, sketch and label the lever system operating at the elbow during the movements from position A to position B. Again, I want you to attempt the question, 2 to 3 minutes. Shouldn't take you any longer than that. Pause the video at this point and then I will explain the question once you've done that. Okay, so pause now. Right, chaps, so this type of question, this is the 3-mark question that I was telling you about. Now, using figure 1, name, sketch, label. So you have got to name the actual lever this time. You have got to draw it and you've got to label it, all for 3 marks. You can't just chuck something in that box and hope for the best. Okay, it needs to be full, clear, good exam practice like I did in the earlier question that was a 1-marker. Now, operating at the elbow during movements position A to position B. So, good exam practice that I've taught you before. When it says from point A to point B, the first thing you do is just scribble out point A. Okay, that is not the movement we are interested in. We are interested in the movement of position B. We identify what the movement at the elbow is. Hopefully you identify that that's extension. Right, that means it can only be one type of lever. Elbow extension. Elbow extension is our first class lever. Must write first class lever, not first lever or 1. Okay, it's then asking you to sketch. Again, you would use a ruler, but I'll just freehand. There's my seesaw. I'm then going to make sure I write in 1, 2, 3, F, L, E, just so I'm in no doubt as to what goes on it. We know it's a first class lever. That means my fulcrum goes in the middle. Just remember here, this is the one where the effort points down. Doesn't matter if it's the top or bottom, but it points down. Okay, and then our load will go on top on the either side. And again, it doesn't matter if the load's the other side and the effort's the other side as long as the fulcrum is in the middle. Then our last set of marks are making sure that we go effort, fulcrum, load or resistance. Okay, so 3 marks, first class lever, the drawing actually correct, and then all the labelling correct gives you 3 marks. So 1 mark for the 3 labels, 1 mark for the actual drawing, 1 mark for stating the fact it's a first class lever. Okay, let's go again. All right, so another question. This is going to save you, in fact, another 2 questions for you this time. This is just going to save you doing any work outside of the lesson this time. So 2 questions here. No picture for that first one. All right, so name, sketch and label the lever system operating at the knee during running. And then the second question, using figure 1, name, sketch and label the lever system operating at the ankle joint from position A to position B. Again, pause the video at this point. It will take you a couple of minutes to get this correct. Pause the video and then I'll explain the answers once you've done them. Pause now. Okay, chaps, so name, sketch, label, lever at the knee. Okay, so because it's the knee and it's not an elbow and it's not an ankle, we automatically, or we should have automatically known, right, that that is going to be our third class lever. Again, good practice, always write third class lever in the top. Our next bit of good practice, 1, 2, 3, F, L, E. We know it's a third class lever now, so our effort is going to go in the middle. Draw your seesaw. Effort pointing upwards. Load on one side. Fulcrum on the other even. And then we label underneath fulcrum, effort, load or resistance. Okay, again, that's only a 2 marks. It could be a 3 mark question. 1, this is all correct. Make sure we label, we draw it correctly. Third class lever, we name it. It says name, sketch and label. Should be a 3 mark question really. Okay, the second one, the picture is there to try and confuse you. Okay, you've got to just make sure you've read the question properly and you fully understand what's going on. It's asking you ankle joint from position A to position B. For this photo and the fact that it's asking you about a lever, it doesn't actually matter, right, whether it's position A or position B, because the lever is exactly the same. Again, good practice. We name the lever. We know because it's ankle, that's going to be a second class lever. 1, 2, 3, F, L, E. Always write that. You're going to get bored of me saying that, but we're always going to write that. We know it's a second class lever. There it is. Draw your seesaw. Load goes in the middle. Effort on one side, pointing up. Fulcrum underneath. Okay, doesn't matter if the effort is the other side or not. So that top bar, as long as it's pointing up, it's fine. But we then make sure fulcrum, load or resistance and effort, and we have got all 2 marks there easily, if not 3. But like I said, that was quite a confusing picture. All right, and I've seen people get this wrong in an exam because they've seen it and gone, oh, brilliant, it must be about elbow extension there. So they've gone first class lever rather than third class, rather than second class. And then they've also got confused because it says point A to point P. It doesn't matter about the movement type on this picture because it's asking you about the lever, not the movement type. Okay, so one more question. Okay, final question to go. And again, I just want you to pause very briefly. This one won't take you very long, hopefully. Okay, but state one mechanical advantage and one mechanical disadvantage of the lever system that is being used at the right ankle on the runner in figure 1 when he moves from position A to position B. Okay, pause the video again, complete the question, and then I will go through it at the end. Pause now. Okay, final answer to go through then. All it's asking is what is the mechanical advantage and disadvantage of this type of lever. So, outline which lever it is. You will say, it says 2 marks, but you are going to say this is a second class lever. Second class lever. You are then just going to put the advantage of this. It can lift heavy loads. If you really want to show your knowledge, you don't really need to, okay, but little effort needed. You're then going to say the disadvantages is, or are even, disadvantages are slower movement, and little flexibility, or I actually prefer limited range of movement. Limited range of movement. Okay, so hopefully you've understood that. Like I say, it is a confusing topic. It's a difficult topic to get your head around. It took me a long time to do it. Like I say, I struggled at school. I struggled through university when I did it, but I now fully understand it. That's it for the questions. And now all you need to do is submit your work as normal. Okay, so we've completed all the questions we need to. There's no extra 9 markers and stuff like that. That was quite a long lesson this time and quite complicated content in one respect. So take a photo or scan in the work, the notes that you've done, the tasks that you did, the drawings that you've done, and the exam questions. Email them to my school email. I'll just have a look through them and just make sure everything's correct and you've marked them correctly, and provide some feedback next week. Again, I hope you found the lesson useful. It is difficult content, so if you do have any questions, please email me. If you're struggling with any of your work, email me and I'll help you as best I can. Again, there'll be more lessons the week after. We're getting to the end of the content now, which is great. We're almost complete in terms of what we need to know, but we've got some slightly more difficult content again to go before we do finish up. Okay, thanks chaps, take care.